Sup fuckers, another day, another math problem. So, the numbers 1 to 100 are written on the blackboard. And so if someone goes up and picks two numbers at random and then exchanges them, erases them and exchanges both of them with the sum of the two. If he keeps on doing this forever, will the last number be even or odd? That is the question. So at first we'll just try. So what happened? Okay, say I go up and I pick these two numbers. So what do I get then? Well, yeah, I would erase them and I would put a 5 in both places. So and okay, so if I would do those two again, I would end up with two tens. And if I did those two, then I would have a 10 and a 4, so I would exchange both to 14. And if I then did those two, then I would exchange both with 15. So you see, we can like switch back and forth between even and odd. So this is basically just a question. If we keep on doing this forever, when will we reach a stable state? Where, well, yeah, exactly. Where a state where either like all are odd or all are even and we can't change either one. So, uh, by doing this, because we only care if they're even or odd, we can just represent all the even numbers as zeros and all the odd numbers as ones. So we have one, and in the original series we have zero. Sorry, I can write it as it is. We have one there, we have one there, one there, 0, 1, 0, all the way up to another 0. So at the start we have 50 zeros. Yeah, we have 50 zeros and we have 50 ones. So, okay, now I ask you, we have three different cases when one picks numbers. So we have the first case where they pick two even numbers, a 0 and another 0. And then we exchange that for the sum, which is 0 plus 0. So this just becomes another two other zeros, so we don't change the standing. We still have 50 zeros and we have 50 ones. And then we have another case where we have a 0 and a 1. So what do we get then? So we have the 0 and the 1, we erase them, and we exchange them with two ones. So we've erased one 0 and exchanged it for a 1. So what we have is that we have 49 zeros and 51 ones. So basically we have minus 1 0 and plus 1 1. And if we pick two ones, what do we get then? Then we get, so we pick two ones and we exchange them for the sum. The sum of two even numbers is, sorry, the sum of two odd numbers is even. So we erase two odd numbers and we exchange them with two even numbers. So we get 52 zeros and 48 ones. So we got plus two zeros and minus two ones. So, okay, so now we know that picking two even numbers doesn't change anything. Picking an even and an odd gives us one less odd and one more even. Sorry, opposite. One less even and one more odd. And if we pick two even numbers, we get two more odd ones and two less. Sorry, two more even ones and two less odd ones. Fuck me. Um, so basically, what does this mean? Well, we can look at it in this way. If we want a stable state, we want that. Well, okay, sorry. We'll just, since we have these two like moves, which things that can randomly happen, we know that we can always pick two odd ones and make them two even ones, and then we can do this two times again, and then we're back at the same standing that we were. So we can repeat this pattern. But if this continues forever, then every possible event will happen. So as long as we are like in between, we have more than two zeros, more than two ones, and well, yeah, if we're like in the middle, this can always happen. We can always repeat this pattern. So what are the extreme cases? Well, we can start with the case that we can't do this. So we have the least extreme of that is that we have okay, we have zeros and ones. So we have that we have 1 1 and we have 99 zeros. So what can happen then? Well, yeah, of course we can pick two even ones and then nothing changes. But if we pick an even and an odd one, then we end up with, so this is like the only relevant case, then we get that, then we get 98 zeros and 2 ones. And then we can like save the situation if we want to think about it that way. Um, let's look at the other case. So if we swap this around, so we have one even number and 99 odd ones. What can we do then? Well, we'll just write it out. We have one odd number and 99, one even number and 99 odd ones. So what we can do, we can pick this, which would make it one less odd ones, even one. So we have that we get 0 even ones and 100 odd ones. Or we can pick two. Well, yeah, sure. We'll regard this first. So now we have all odd numbers. What happens now? Well, we can obviously still do that and make some even numbers up. So this will automatically go to 1, so 2 even numbers and 98 odd ones. So we know that this is not a stable state. We can't be here. But if we then go back here, what can we do now? Well, we can, because we know that if this continues forever, we will arrive at every possible point until we arrive at a stable state. So a state where like nothing changes. So in this case, if we look at this, what can we do here? But obviously we can pick two even ones and nothing happens, or we can pick an even and an odd one, and then we get one less. Yeah, we'll just do this again. So we get 97 and 3, and nothing really special happens. But if we pick this one, what happens then? Then we get all evens and no odd ones. And here, well, because we only have even, we can only pick this one, and that changes nothing. So this is our stable state. Because if we're here or there, anywhere else, something else can happen. We can change the amounts of even and odd numbers. So we will at some point arrive at this. We can never have the same number everywhere, but every number will be even. And that we can guarantee. And this will continue forever because the only possible move here is two evens, which changes nothing. So this is our stable state, but then we will some time after an infinity or two arrive at. And then the last number will be all numbers will be even. And that's the final answer. All for me. Auf Wiedersehen.